For a sequence, un is equal to n squared plus 2n divided by n plus 3. Find the first three terms of this sequence and find the term which has a value of 33 over 4. So to find term 1, the first term, we're going to get u1. So what we do is we swap the n in every part of this formula for a 1. So it's going to be 1 squared plus 2 times 1 divided by 1 plus 3. And 1 squared is 1, 2 by 1 is 2, and 1 plus 2 is 3, and 1 plus 3 is 4. So u1, or the first term of this sequence, is 3 over 4. To find the second term, or term 2, we're looking for u2. So we're going to swap every n in this formula for a 2. So we get 2 squared plus 2 times 2 divided by 2 plus 3. 2 squared is 4, 2 by 2 is 4, 4 plus 4 is 8, and 2 plus 3 is 5. So u2, or the second term of this sequence, is 8 over 5. Then to get term 3, or u3, we're going to swap a 3 for every n in this formula. So 3 squared plus 2 times 3 divided by 3 plus 3. 3 squared is 9. 2 by 3 is 6. And 9 plus 6 would be 15. And 3 plus 3 is 6. And 15 over 6 will simplify to 5 over 2. So the third term of this sequence is 5 over 2. Okay, so the next part of our question wants us to find which term has a value of 33 over 4. So we're going to let our formula equal to 33 over 4. So we have n squared plus 2n over n plus 3 equals 33 over 4, and we're going to cross multiply. So it's going to be n squared plus 2n multiplied by 4, and then 33 times n plus 3 on the right hand side of the equal sign. 4 by n squared is 4n squared, 4 by 2n is plus 8n. Bring down the equals. 33 by n is 33n. 33 by 3 is 99. Then we're going to get all our terms on the same side. So 4n squared stays where it is. The 33n is going to come over the equal sign and become minus 33n. The plus 8n stays where it is. And the plus 99 comes over the equal sign and becomes minus 99. And that's equal to 0. We bring down the 4n squared. Minus 33n plus 8n is minus 25n. Bring down the minus 199 and the equal 0. Now we have a quadratic that we want to factorize and then solve. So to factorize this, we're going to bring down the 4n squared. We're going to see that this is a minus, so we know that our signs will be different. So we need to choose factors of 99 to go in the end of both of our brackets. So we're going to go with plus 11 and minus 99, because if we do 11 by n, we get 11n, and 4n by minus 9, we get minus 36n, and minus 36n plus 11n give us minus 25n, which is what we want here. Otherwise, we could have factorized our quadratic using the grouping method, so I'll just show that example as well. So we have 4n squared minus 25n minus 99. We bring down the 4n squared and the minus 99. 4 times 99 is going to give us 396. The factors of 396 are going to be 2 by 198, 3 by 132, 4 by 99, 6 by 66, 9 by 44, 11 by 36. So if I go with 11 and 36, I can put those together to end up giving me minus 25. So I'm going to have plus 11n minus 36n gives me minus 25n. So I'm going to factorize the first two terms. So I'm going to have n times 4n plus 11. And then I'm going to factorize the right two terms. And I'm going to have minus 9 times 4n plus 11. Putting those together, end up with 4n plus 11 times n minus 9. So that's another way to get my factors. Alternatively, I could have just used my quadratic formula to solve. Okay, so now I'm going to solve. So I take my two factors over here. So I've got 4n plus 11 equal to 0 and n minus 9 equal to 0. And then I just solve for n. 4n plus 11 equals 0, so 4n equals minus 11. So n equals minus 11 divided by 4. And then n minus 9 equals 0, so n is equal to 9. And I have to go with 9 because n has to be an element of the natural number set. So n has to be a positive whole number. So n is going to be 9. Because we can't say that we have minus 18 terms. We can't say that we have 2.5 terms. And we certainly can't say we have minus 11 over 4 terms. We have to have a positive whole number for n.